In this problem, notice you're solving exponential functions that supposedly have the same base. But when looking at it, initially the base does not look the same. So notice we got 144 over here on the left, and we have 1 over 12 on the right. Now, you could use a guess and check method to try to figure out how to convert this 144 into 1 over 12. And once you got that power, you would then distribute it to this power right here that's an expression for the 144. However, if you're guessing and checking, that could take a very long time. And this is going to be where it would be a good idea to use a logarithm. So at least me, when I'm looking at it, I don't know what power to put it to get it to be 1 over 12. But I know that if I convert it to a logarithm, I can. And let me show you what I mean. So if I'm getting a problem like this, the first thing I would do, and so I'm going to write step 1, I'm going to put an arrow. I'm going to put convert 144 to 1 over 12. That way you have the same base using the properties of logarithms. So that's what we're going to do first. And if you're not familiar with that, if you forgot about logarithms, go back and look at my video on working with logarithms. I have one that has tutorials on an intro to logarithm. And then I got another that would be very helpful that's going to show you the process that I'm doing right now. And it's actually called Exponential to Logarithms to solve for x. If you watch that video, you're going to see the same process that I'm about to do to this 144 to get it to be equal to 112. Because that's my goal. So my goal is to make these have the same base. And remember that when we're talking about exponents, for instance, and I'm just going to write this right, we got 144 to the power of x, and I'm going to say is equal to 1 over 12. I want to make it the same. And in this case, this right here would be base. So actually, you know what, I'm just going to write base. And this part up here is the exponent. So I'm going to set it up just like you see here. And once I figure out how to convert 144 to 1 over 12 using a different exponent, I'm going to go ahead and then solve this equation, because then the bases will be the same. So let me show you what I mean. So I have 144, and actually I'm going to write my exponent with a variable x, because I don't know what it is. I don't know what this exponent needs to be to change 144 to 1 over 12. I'm going to set it equal to 1 over 12, because that's my goal, is to make these two bases the same. Now I'm going to go ahead at this point and convert this to a log. So our logarithm rule says that anytime we have an exponent, we could actually rewrite this as x times a log of 144. So this is just me rewriting it, right? So I'm taking an exponent and I'm writing it as a logarithm. And I'm going to set this equal to the log of 1 over 12. And while this doesn't necessarily solve it, right? It didn't turn it into the same base. It is going to let me solve for what exponent I need to convert it to 1 over 12. Now what I'm going to do is use inverse operations. Right now x is being multiplied to log 144. And so I'm going to divide out log of 144 on both sides of the equation. Now over here on the left, anything divided by itself is just 1, so we like to say they cancel. I am simply left with x is equal to, and now I'm going to divide this out in a calculator, and whatever I get for my answer is going to be the power that I need to use to convert 144 to 1 over 12. So I'm going to get my calculator real quick, and I'm going to type in alpha y equals enter to get my fraction bar, and then I'm going to type in log 1 over 12. So log 1 over 12. And then that's divided by log 144. So log of 144. I'm going to hit enter, and notice it gives me negative 1 over 2. So if I want my bases to be the same, all I have to do is take 144 and put it to the power of negative 1/2. And let me show you what I mean by that. If I were to take my calculator and I go ahead and I type that in, 144 to the power of negative 1/2, and now it becomes this value, 0.083333. Now if I hit math, enter, and turn it to a fraction, it gives me 1/12. So you can see that. So all I did was hit math, enter, and it converted 144 to the power of negative 1/2 to a fraction, which is 1/12. And that's what we wanted right here. So we want to have the base be the same. So now I know what my exponent is, so I'm going to rewrite this. So this is actually going to be 144 to the power of negative 1/2, and then I'm going to write this expression right here, the rest of this expression, 6x minus 12 times 6x minus 12, and that will be equal to 1/12 and we have 3x minus 6 to the power of 3x minus 6. Okay, now these are equivalent, because if I do 144 to the power of negative 1/2, it is going to give me 1/12. So these are equivalent values, and I'll prove it to you once again. I'm just going to get my calculator. If I do 144 to the power of negative 1/2, it gives me this 0.083 repeating, right? If I were to put in 1 divided by 12, so that's 1/12, it gives me the same value. So by me adding this negative power of 1/2 to the 144, it makes it equal to 1/12. So now technically we have the same base. So from this point, what we need to do is we need to go ahead and we need to distribute this negative 1/2 to the two terms inside the expression. So we have the same base now, and so I'm going to rewrite this as simply negative 1/2 times 6x minus 12 is equal to 3x minus 6. So notice at this point, now that I've made them equivalent, I just take what the exponents are and I write them down and set them equal to each other. In other words, this expression is equal to this expression. And I just got to go ahead and distribute and solve for x. So I'm going to go ahead and multiply 1/2 times 6x, and that's going to give me negative 3x. So I'm going to move my camera down for you real quick. And then I'm going to take that negative 1/2 and multiply it to negative 12. So negative 1/2 times negative 12. If I multiply that out in my calculator, that is going to give me positive 6. Now remember, if you're not good at doing these calculations in your head, right, just use the calculator, right? You could have put alpha y equals enter, negative 1/2, and then you could have multiplied that to negative 12, and it would have given you 6. So again, you don't have to do these in your head like I am. You could go ahead and use your calculator for it. Now this is going to be equal to this whole expression over here on the right, 3x minus 6. And from this point, we want to go ahead and move all the variables to the left and all our constant values to the right. So I'm going to move this 6 over to the right by subtracting it, right, using inverse operations. So we have to subtract from both sides to keep it balanced. That becomes 0 on the left side, and negative 6 plus negative 6 is going to leave me with negative 12. And then I'm going to go ahead and move this 3x over to the left. So I'm going to do it by subtracting, because over here it's a positive 3x. So I do the inverse operation, which is subtracted. And I'll subtract it on this side. So I have negative 3x plus negative 3x, and that gives me negative 6x's. So we're almost done. We're just going to continue this. Now I need to isolate my 6 by dividing it out for the x. So divide both sides by negative 6. And I end up with x is equal to positive 2. So all that work that we did was so that we can know that x is equal to positive 2.